In this video, we'll be discussing multi-stage experiments and how to calculate probabilities of multi-stage experience. There's two main subjects within this section that I want to cover that are really going to help you when you're working on experiment problems and calculating probabilities. Those two concepts are creating tree diagrams and probability trees, and then finally the multiplication principle. So when we talk about a multi-stage experiment, what we're referring to is an experiment that has multiple parts, which are often either repetitions of the same action or two different actions. So in a second, we'll do an example where we flip a coin, that's the first part of the experiment, and then we roll a die. That's the second type of the experiment. Or it could be an experiment where we flip a coin, then flip a coin, and then flip a coin again. So at a base level, the most simplistic way to calculate probabilities of multi-stage experiments is to draw probability trees. So let's use this example as a guide. Let's say that in an experiment we are going to toss a coin and then we are going to roll a die. The first thing that you should already know how to do is to create the sample space. The sample space is the set of all possible outcomes, and so when we flip a coin, we're either going to end up with the heads or we're going to end up with the tails. Assuming that it's a fair coin, these are both equally likely outcomes. They each have a probability of 1/2. Then, regardless of whether we get heads or tails, when we roll a die, we have the option of getting a 1, a 2, a 3, a 4, a 5, and a 6. Each of these branches in the probability tree have a probability of 1/6 of happening. I'm not going to fill in the rest of these, but all of these branches are 1/6. And then you could imagine that we would have the exact same thing over here, 1 through 6, with each of these being a probability of 1/6. The probability of any specific event happening is the multiplication of the probabilities along that path. Let me restate that in a way that's hopefully more clear using this example. Let's say we want to know the probability that we flip heads and then we roll a 1. There's only one way in this example that can be done. We flip a head, 1/2 probability, and then we roll a 1, 1/6 probability. A common mistake, please do not do this, would be to add those two probabilities together. To say, well, 1/2 plus 1/6, and that's my answer. That is incorrect. That would actually be an increased probability where instead what you want to do is you want to multiply those two numbers. And when you do that, you end up with a probability of 1/12. Now, with that being said, let's say we change the scenario slightly, and let's say we want to know the probability that we flip heads and then we roll an even number. In this case, there's a couple of different ways that we can approach it, but you'll notice that the probability that we flip heads is still 1/2, but then we need to multiply that by the probability that we will roll an even number. The probability that we will roll an even number is the sum, not the multiplication, not the product, but the sum of these probabilities. So the probability that we will roll an even number is actually 3/6 or 1/2. So in this case, the probability would be 1/4 that this occurs. Again, you can see how if you mistakenly added these two numbers together, so do not do this, but if you added these probabilities together, you would end up with a probability of 1, which we already know means that that would be a certain event. Well, it's clearly not a certain event. It's not 100% likely that you're going to flip a heads and then roll a 1.